All right, today's lesson is about complementary angles. Now, in general, when we talk about complementary angles, all right, we're talking about angles that add up to 90 degrees. So just, forget the triangle for a second. Complementary angles. If I say one angle is 20 degrees, a complementary angle is going to be 70 degrees. All right, these two angles would be complementary because 20 degrees plus 70 degrees equals 90 degrees. So complementary angles add up to 90 degrees. Now, we know that all of the angles inside of a triangle, any triangle, add up to 180 degrees. But if you have a right triangle, all right, you start off with 180 degrees, but right away, 90 degrees are taken up by the right angle. So if I subtract 90 from 180, that leaves 90. That means the other two angles have to add up to 90 degrees automatically. That means the acute angles in a right triangle will always be complementary. So like I said, if we know that this angle is 70 degrees, then that means this angle has to be 20 degrees. Immediately. They have to be complementary. They have to add up to 90 degrees. If this angle is 50 degrees, this angle is 40 degrees. 50 plus 40 is 90. Okay? If this angle is 45 degrees, this angle has to be 45 degrees. They have to be complementary. They have to add up to 90. You get it. Now, if I give you some random number, 60, this is 67 degrees. If you want to find this other angle, which I will call theta, all right, that's the Greek letter theta, get used to it. It's traditional to use theta as a variable to represent an angle, but it's just a variable, just like if I put an x here or something like that, it's just another variable. So theta, it is. If I wanted to know what theta would be, if I needed to calculate it, I would go, okay, 90 minus 67. Okay, because that would give me the number that would make this add up to 90. So in this case, that would be 23 degrees. Okay? So, put it to you another way. Whoa. No, well, let me do one more example first. So, if I told you that this angle right here was 31 degrees, again, if I wanted to find out what this angle is, I would do 90 minus 31 degrees. Okay? Now, so what about this? What if I put a variable here? What if I said this angle was theta? And I want to know an expression for the other angle. Okay, well, if this angle is theta, then the other angle is going to be 90 minus theta. All right, so I don't know what it is, but I know if this is theta, I know that this will be 90 minus theta. Okay, so that's concept number one, theta, 90 minus theta. Okay, now I could put it the other way around too. If I told you that this angle up here was theta, well, the other angle must be 90 minus theta. Okay, now hold that in your head. Let's come back to that for a second. Now, let me convince you of the following. Let's go back to this. Say this is 20 degrees and this is 70 degrees. Okay, sine and cosine. What if I told you that the sine of 70 degrees is going to always equal the cosine of 20 degrees? Okay? What if I told you that would work for any complementary angles? So say if this was 60 degrees, this would of course be 30 degrees. They got to add up to 90. All right? So then I'd be telling you that the sine of 60 degrees will equal the cosine of 30 degrees every single time. Okay? So what if I told you that this was, let's say if I call this angle A and I call this angle B, all right, we'll call this angle C. Then that would mean that in this right triangle, the sine of angle A will always equal the cosine of angle B. What if I told you that? Okay, and what if I put it to you this way? Remember when I had the theta and the 90 minus theta? Let's go back to that. So say if this is theta, and so that would make this 90 minus theta, okay? Then that would mean the sine of theta will always equal the cosine of 90 minus theta. Okay, or I could have said it the other way around. Whoops. I raced too much, my friend. I could have said it the other way around, and I could have said the sine of 90 minus theta will equal the cosine of theta, okay? Because I'm saying the sine of one angle will equal the cosine of the other angle. Doesn't matter which one is which. Okay? That is what I'm telling you is true. Now let me try to convince you of that for a second. Let me try to convince you of that, okay? For example, all right, let me use one that you would automatically know. So if this is 30 degrees and this is 60 degrees, okay? Let's say that the hypotenuse here is 10, okay? Because of the pattern that we learned about a 30, 60, 90 triangle, the hypotenuse is always double the short leg, so that means this is going to be 5. And the long leg is the short leg times radical 3. So this would be 5 radical 3. Okay, let's play around with this for a second. Okay? Now, I am claiming to you, my friends, that the sine of one angle, like say it's 60, is going to equal the cosine of the other angle, say 30. Okay? Now, is that true? So let's see, what would be the sine of 60? So the sine is opposite leg over the hypotenuse. Okay, so the sine of 60 would be 5 radical 3 over 10. Okay, and I could reduce that, but I'm not going to do it right now. Now the cosine of 30 degrees is going to be the adjacent leg over the hypotenuse. Well, the adjacent leg is 5 radical 3, and the hypotenuse would be 10. Okay, so that would be 5 radical 3 over 10. Okay, so like we're seeing, it's going to be the same thing both times. And that, of course, is going to happen every time, because for the 60, this will be opposite, but for the 30, this will be adjacent. And that would be true no matter what these angles are. So I'm sort of proving to you that what I said is true. So if you have a right triangle, the sine of one angle will always equal the cosine of the other angle. That's the background that you need for this lesson. Okay, so with that in mind, so we know that the sine of one angle equals the cosine of the other angle if A and B are complementary angles. Complementary. Okay? That means that the angles need to add to 90 degrees. All right, write sine of 52 in terms of cosine. Okay? All right, it helps to think of these angles as being inside of a right triangle to help us shape our minds around it. So if the one angle is 52 degrees, the other angle, the complementary angle, we'll just go 90 minus 52. And of course that is 38 degrees. So if the one angle is 52 degrees, the other angle is 38 degrees. So the sine of 52 degrees should equal the cosine of 38 degrees. Okay, write the cosine of 71 degrees in terms of sine. All right, that's fine. Okay, let me just start over. The cosine of 71 degrees. So if this is 71 degrees, then this is going to be 19 degrees. Okay, so we're supposed cosine of 71. So the cosine of 71 degrees should equal the sine of 19 degrees. All right, the cosine of one angle should equal the sine of the complementary angle. So there it is. Okay, find the two angles that satisfy the equation below. Okay, well here they're using this rule that I've just been showing you. The sine of one angle is equal to the cosine of the other angle. But again, that's only true if the angles are complementary. Okay, that's only true if the angles add up to 90 degrees. That's the key. So that means these two angles must add up to 90 degrees. All right, in other words, x plus 5 plus 4x plus 10 must equal 90. All right, these have to add up to 90 degrees. So I need to solve this equation for x, and I'll have to plug that back in to figure out what the actual angles are. So combining like terms, all right, because these parentheses are just grouping symbols for us. So we have x plus 4x, that is 5x, and 5 plus 10 is 15, is equal to 90. All right, subtracting 15 from both sides. All right, that's going to give us 5x is equal to 75. So of course then I would divide by 5 on both sides, and that gives me x is equal to 15. Okay? But that's not the answer. We were asked to find the two angles that we are shown here. Okay, so I need to plug those back in. So if I take this 15 and I put the 15 in for x in both places, okay, then what do I really have? So 15 plus 5 is 20. So that makes the sine of 20 equals. Now over here, 4 times 15, we'll see, 2 times 15 is 30. So 4 times 15 must be 60. So this is 60 plus 10, so that's 70. Okay, so I've got the cosine. Well, okay, that was silly also, because, all right, it was good to go ahead and verify that, but they have to be complementary. So if this was 20, of course, this was going to be 70. All right, but rather than just assume it, it's self-checking, all right? It's good to just plug it back in and see what you get and make sure you are getting complementary angles, because if you got 20 and 50, that means you did something wrong. So anyway, the two angles, I'll just write them separately, are 20 degrees and 70 degrees. That's the actual answer to the question. That's the two angles that they're talking about. Okay. Good times. Looking at number 4. All right, pause the video. Try to do number 4 by yourself. And then start the video again and see if you were right or not. Okay, if you were smart, then you pause the video. If you're foolish, you're just going to watch me do another one. All right, again, these two angles have to add up to 90. So that means 3x plus 2 plus x plus 44 have to add up to 90 degrees. 3x plus x is 4x. 2 and 44 make 46. That must equal 90. Subtracting 46, subtracting 46 from both sides is going to give me what, 44? So that'll give me, let me bring it around here. So that'll give me 4x is equal to 44. And then I'm going to divide both sides by 4. And that'll give me x is equal to 11. Okay, so fine, x is 11. So I'm going to take that 11 and I'm going to put it back in here and here. Okay, so 3 times 11 is 33. Plus 2 is 35. Okay, so that gives me, I just feel like changing colors. I'm getting bored. So that's going to give me the sine of 35 degrees. Okay, now these angles have to be complementary. So the other one had better turn out to be the cosine of 55 degrees because that's complementary. But let's do it and check. So I have a 11 plus 44. Okay, so that is going to be 55. Okay, so cosine of 55 degrees. So 35 degrees and 55 degrees. Okay, that's the answer for number 4. Now look at number 5. Which property can be justified using the ratios in triangle CAB? What do they have going on over here? All right, well, we know that the sine of one angle is going to equal the cosine of the other angle, okay? So we know, for example, if I call this theta, then that would make this over here 90 minus theta. So we know that the sine of theta will equal, the cosine of 90 minus theta. Or I could have said it the other way around, and I could have said the sine of 90 minus theta will equal the cosine of theta, all right? Sine of one angle will equal the cosine of the other angle, all right? So if I just use the letters instead, okay? So if this is angle B, all right, then you know, if I'm saying that this is like B degrees, if you will, if that's B degrees, then this other angle over here is going to be 90 minus B. Okay, I'm just using B instead of theta. Okay, so that means the sine of B is going to equal the cosine of 90 minus B. Okay, or the sine of 90 minus B is going to equal the cosine of B. Okay? In other words, the sine of one angle is going to equal the cosine of the other angle. Okay? So that's all that's happening in this problem. Because I'm looking at the answers. They're not mentioning the 55 or the 35. Okay? They're not mentioning that, so you can pretty much ignore that. Okay? And in fact, I'm seeing, you know, I'm seeing A and B, okay? But, yeah. So I could say, like, the sine of, like, if I call this B, then I could call this 90 minus B, okay? So here are some things that they could have said. These are things that are all true. I could say the sine of B is equal to the cosine of 90 minus B. Okay, that would be true. All right, I could have said, you know, we have a variable here already, it's A. So I could have said the sine of B is equal to the cosine of A. Okay, that would also be true. So this is the type of thing I'm looking for in the multiple choices. Okay, so let's see. Sine of B is equal to the cosine of 90 plus B. No, it's not that one because it's not plus. All right, the sine of A is equal to the cosine, the cosine of A is equal to the sine of 90 minus B. No, that's nonsense, all right? If I'm just going to say the cosine of A, then the cosine of A will equal the sine of B. Okay, just plain and simple, right? The cosine of one angle is going to equal the sine of the other angle. So cosine of A would equal the sine of B, plain and simple, not 90 minus B, so that's not the answer. Okay, the cosine of B is equal to the sine of 90 minus B. All right, that's what we've been talking about this whole time. That's going to be the answer. Okay, cosine of B is equal to the sine of 90 minus B. because B is one angle and 90 minus B would be the other angle. Okay, so that's the answer. Okay, which pair are equal trig values? Well, if I'm going to scan down, first of all, we've been talking about sine and cosine this entire time. So I will worry about the, wait, I lost my marker for a second. Technical difficulty. I will worry about the tan, sine, sine. I'll worry about that later. What we've been learning about all day today are these. So I'm going to focus on these. So I know that the sine of one angle will equal the cosine of the other angle if the angles are complementary. So if are either of these adding up to 90 degrees? Okay, well 65 and 65, all right, 60 and 60 is 120, all right, so this is 130. So the answer is not D because those are not complementary. All right, so how about C? 36 and 54, yeah, 36 plus 54 is 90 degrees. These are complementary, so that means this is the answer. All right, my pen's not working. I'm actually drawing this with my finger right now. Maybe I'll use the highlighter. Yeah. Okay, so this is the answer because these are complementary. Sine of one angle will equal the cosine of the complementary angle. That's what we've been learning all lesson long. Now, I'm really hoping this is the last problem because my pen stopped working and this is tedious. Is it the last problem? Yeah, that was the last problem. Okay, guys, I hope this lesson was helpful to you. I know it can be a little tricky, but please, if you find yourself just watching me and copying off of me, you're only going to learn 10% of what you need to learn. You have to be doing these problems by yourself. So if you were just watching me the whole time, you really need to go back and redo this entire lesson by yourself. Okay, make sure at some point you do every problem by yourself. That's the only way you're going to learn for real.